Today we will be looking at how to test a difference in proportions. To decide which of the two hypotheses is correct, we need to consider the difference in the Cardinals' performances at home and on the road to see if this difference provides convincing evidence that the Cardinals have a greater ability to win at home. The difference between the Cardinals' winning percentage at home and their winning percentage on the road is 37.5%. We find that by taking 75 and subtracting 37.5. We refer to this difference as the test statistic, since it is the evidence we will use to test the hypothesis stated earlier. We want to see how likely it is to get a difference of at least 37.5%, assuming the null hypothesis is true. In order to simulate this, we do not use a spinner. We will take 8 index cards, cut them in half, so you have 16. On 9, you will write a W for win, and on 7 an L for loss. After you shuffle the cards, deal 8 cards into one pile for the simulated performance at home, and 8 cards in another pile for their simulated performance on the road. Calculate the winning percentages in each pile, subtract to get the difference, and repeat. So this is an example of a simulation where I took the cards and separated them as stated before. I got a winning percentage at home of 62.5% and a percentage on the road of 50%. The difference would be 62.5 minus 50, which is 12.5. When you're doing these differences, you can get a negative number, that's okay, but you have to get one of the numbers listed on the screen. Negative 75 up to 75 in increments of 12.5. If you look on the number line and look for 37.5 or 0.375, since this is done in proportions, you would take everything from 0.375 up and count it. So in 12 of the simulated 100 seasons, the Cardinals had a difference equal to or greater than 37.5%. Because this simulation was conducted assuming there is no difference in ability at home and on the road, and because the simulation reveals that a difference in performance of 37.5% is somewhat likely to happen by random chance alone, we do not have convincing evidence that the Cardinals had a greater ability to win at home than on the road. After all, the results of the simulation show that their superior performance at home could plausibly be the result of random chance. The fraction 12 out of 100 is called an approximate p-value. It estimates how likely it is to get a difference of at least 37.5% by random chance, assuming the Cardinals have the same ability to win at home and on the road. So making conclusions. You need to be really careful when you make conclusions. I am not going to hold you to saying the p-value is very small or is small. Small is good enough. But you will have to know which values that you would use for rejecting the null hypothesis or failing to reject. You never, ever say except. If the p-value is very small, which is less than 0.01, which would be like 1 out of 100 or 0, you reject the null hypothesis. We have very convincing evidence to support the alternative hypothesis. When you write these out, and we will go over this a bunch, you will not put null hypothesis. You will put the actual wording of the hypothesis. If the p-value is small, which is between 0.01 and 0.05, not including 0.05, you also reject the null hypothesis. If it is greater than or equal to 0.05, which is 5 out of 100, you would fail to reject the null hypothesis. Tennis player Rafael Nadal has been called the king of clay for his excellent play on clay surfaces. But does he really have a greater ability to play tennis on clay courts compared to grass or hard surface courts? Here's a two-way table showing the results of his matches from 2009 and 2010. A says construct a graph to compare Nadal's performances on each surface and briefly describe what you see. If you look at them, he had a 95.7% winning percentage on clay, 79.3% on other. So we would say Nadal performed better on clay than on other surfaces. State the hypotheses we are interested in testing. So our HO will be Nadal has the same ability to play tennis on clay and on other surfaces. Our HA will be Nadal has a greater ability to play tennis on clay than on other surfaces. What is the value of the test statistic? Well, his clay was 95.7 and his other surfaces was 79.3, which gives us a test statistic of 16.4%. Describe how to simulate the distribution of the test statistic, assuming that Nadal has the same ability to play tennis on clay surfaces and on other surfaces. So we're going to take 162 note cards, and write W on 136. And L on 26. So these numbers come from over here. We have 162 total matches. He won 136 total and lost 26 total. Then we're going to shuffle. And divide them into two piles. $46 will be clay and 116 will be other surfaces. Calculate the winning percentage in each pile. Subtract clay minus other surfaces. Plot it on a dot plot and repeat many times. "100 trials of the simulation were conducted, and the value of the simulated test statistic for each trial was recorded on the dot plot at the right. Describe what this information provides." So we would say the dot plot shows the possible differences in winning percentage that could occur by random chance, assuming that he has the same ability on both types of surfaces. Using the dot plot and the test statistic, estimate and interpret the p-value. Where our test statistic was 16.4, and if you look, there is one lone dot that is that high. So our p-value would be 1 out of 100, which is 1%. State an appropriate conclusion. So we would say, because the p-value is small, we reject our null hypothesis, and you can put HO for that. And then you would say, we have convincing evidence that Nadal plays better on clay than other surfaces. It is very important that both for the dot plot and for the conclusion that you are using the correct wording. You do not have to write out HO in your conclusion, but you do have to write out your HA in the second part. Likewise, up here for the dot plot, you need to make sure you always say that it could occur by random chance, assuming that they have the same ability.